Hello, everyone, and welcome to Now and Zen. Today we have microtonal theorist Chris Kline here to talk about projective tuning space, 3D printing flutes, and retuning other microtonal music. Welcome, Chris. It's so great to have you on the show.
Hello, it's great to be here.
I knew about some of your work a little bit earlier, but I first became really familiar with what you were doing with projective tuning space at Un12 last year because you came in and had this great presentation ready, and you've created a projective tuning space website where not only can you navigate projective tuning space, but there's a direct connection between it and Lumatone layouts.
So this was developed initially by Paul Ehrlich in about 20 years ago in his paper A Middle Path Between Just Intonation and the Equal Temperaments, which is accessible online. I'll go ahead and share this. All right, you see it.
Yes, the classic paper.
All right, so yeah, this is it's pretty long. Down here, most of the way towards the bottom, he introduces it. It's this diagram here, and like many microtonal people, I was really entranced by it and studied it a lot because it's really complex and seems like there's a lot going on. So because I wanted to find out what was going on with it, I ended up making the entire thing from scratch, and then that evolved into a whole thing, a whole website that's here at projectivetuningspace.com. So here it is. You can press create here to reveal equal temperaments, and then they can map merge and comma merge the temperaments to get new ones, basically. So there we go.
Yay! Look at that.
So here we can see in the middle here, there's a red dot that represents purely tuned just intonation for the prime basis of 2, 3, 5, which is basically just 5 element just intonation. And then surrounding that are several hexagons which serve as a ruler for damage for the tuning optimal tuning. And then there's a bunch of numbers that are lined up, and they form lines. They kind of converge and coalesce into lines. And certain numbers seem to have higher gravity, certain lines seem to have higher gravitation, and it's that's corresponding to the complexity of these temperaments. So basically, what these numbers mean, these numbers actually each mean three numbers. So for 12 here, for example, that means actually 12, 19, 28. So that's called a val or a covector. And if in linear algebra terms, val in regular temperament theory or um, enharmonic terms, whatever you want to call it.
Yeah.
So basically, that means how many steps it takes to approximate of an equal temperament to approximate just intonation. So 12 steps to get to the second harmonic, 19 steps to get to the third, and then 28 to get to the fifth, and all those steps are equal. And we call that 12 tone equal temperament. And you can find you can figure out the patent val, they call it, for any equal temperament just by taking that number and then dividing it by the log to the base p for some prime, 2, 3, or 5 or whatever, and then that number again. So like
Oh,
12 or not that 2, sorry. So 12 divided by log base 2 of 2 gets you to the log base 2 of 2 is just 1. So
yeah.
12 over 1 gets you 12. And then 12 divided by log base 2 of 3 gets you close to 19, a little bit slightly past it, or maybe it's slightly before it, one of those two. It's a little bit off. And then 12 divided by log base 5 of 2 gets you close to 28. And you round them and you get to the patent val, and that's usually typically like the best tuned version. But you can just like stick any three numbers together and like make something, and it's not necessarily going to be a good tuning. For example, like 12, 19, 27 over here. That tunes 5 like way too flat. It's way off on the side here.
Right.
It's no good. But these do provide like structural um relations to it. We can
So,
zoom way out here. This is the overall whole triangle. of all the positive numbers.
Yeah.
But really the good stuff is down here in the middle here, towards the middle.
So
Um,
so you can zoom in and out of projective tuning space continuously on the website that you've created.
yeah, you can increase this here. This is only going up to 100, but I can go up to 1,000 here and it'll put more out. If it starts getting like past like 10,000, it starts to not zoom in very well just due to the limitations of the software that this is developed in.
Like 10,000
Um,
tone equal temperament.
yeah,
Yes.
but
The really cool thing about the geometry of this is when you zoom in and out, you can explore the limits of the space in a way that's much easier to picture than just doing it in stages. And then you can
yeah,
also see that the patterns of crisscrossing lines that have very important intersections where the numbers are larger in size, that pattern kind
yes.
of continues as you zoom
It's
in, and
yeah, it's fractal.
you can never really hit the red dot, right? Because of the math of equal temperament.
Yeah. So
Right.
all the lines are going to be possibly very close to the red dot, but never crossing it.
So the then projective tuning space, if it's showing the connections between temperaments, how would you make the lines from Paul Ehrlich's diagram appear, like the mean tone line?
So I can click I can click on one of these equal temperaments along the line and then click map merge and then it's going to turn blue, say it's ready, and then I click another one and it pulls this whole line out of it. So this one here is mean tone. It tempers out to the interval 81 over 80, which is in vector notation -4 for -1. This is also called a Monzo.
And then Monzo
Um,
refers to the
that
amount of
refers to
crumbs.
yes, so 2 to the -4 power times 3 to the fourth power times 5 to the -1 power equals 81 over 80.
Yeah, yeah, exactly. A really nice shorthand for that. Okay.
Yes, especially for the more complex ones because some of these numbers get absurd.
How did you even start coding this? Like from the beginning? Like what was your process? Day one, you sit down, you got to code projective tuning space.
I put a number in a spot. I figured out I read the on the Zen wiki there's like 3 paragraphs about projective tuning space, like the entire thing, at least on that one page of it. There's more in Doug and Dave's RTT guide, which is it's a very great resource. I would not have been able to build this without them. But it basically describes the way that the space is three-dimensional, and then the axes are scaled logarithmically according to 2, 3, and 5, like those bases of logarithms. And then you have to like look down a line that's like directly down the diagonal away from all equal distant from all three axes. And then every that's just basically like a ruler or like a grid, and then these vowels are just like the coordinates on that grid. And when you project it like that and you make it look two-dimensional as if you're looking at it from that viewpoint, then it comes out like this.
Right.
I'm
Yes.
gonna reset this back to 100 just to remove some of that clutter from the middle.
It might also be good with the projective tuning space app to maybe, since you have the mean tone line, and there are lots of other lines in the graph that you could click, to go over how to change the generator size on the line and
Okay,
then
yeah.
get a Lumatone layout that would correspond to it.
Okay, yeah. Let's go over the generator and I'll go over the Lumatone stuff in a bit.
Yeah,
But
absolutely. We
all
can save
right.
that for later.
Okay. Yeah, I want to go over a little bit more stuff in these first.
Mm-hmm.
So there's 2 dots on this mean tone line. There's a light blue dot and then there's a light green dot. Um, the light blue dot is top tuning or tinny optimal, and then the green dot is tinny Euclidean. So the blue dot is the closest along one of these corner lines of corners of the hexagons, or in certain temperaments, the closest along to like the midpoint. Um, and then the tinny Euclidean is the closest to like a circle that's around the just intonation point. So they're both two different ways of optimizing this entire mean tone. So anything along this line is going to be mean tone. But these 2 points are like two different optimizations for the least amount of damage to the primes, which you can see here on these bars.
Yeah.
So there's tuning optimal tuning, tempers the octave a bit sharp for mean tone, and then the generator here I have it as 4/3, so that's comes out to 5/4, which is a bit sharp. Tuning Euclidean is a little bit different, but this pink dot here is whichever one you currently have set is going to be on that pink dot. There's also the pure octave um, POTT, which is pure octave top, and then POTE, which is pure octave tinny Euclidean. Those project to the exact same points as their non-pure versions, but the
Whoa.
pure octave kind of it comes with more damage to other primes usually.
Oh, I see. So
So
you can't
it's
actually
not
see the damage to the other primes on the chart, but it would show you there in your visual.
it shows in the graph. So there's a TE, it's like mostly kind of condensed, and then POTE, these are it forces two to be pure, and then like everything else just has to deal with that.
Right.
But you can also like change this. So
So you're
depending
dragging the
on
pink dot around, and that's changing the
yeah,
generator size to anything, and it's not
I'm dragging
necessarily
the
what an optimizer
generator
was.
size around, and the pink dot moves accordingly.
Right.
So
And
like
you can
here
kind
about
of
500 cents, that's right at 12 tet.
yeah.
I can also go to this map interval here and find out, for example, like 5/4, um, 2 periods and -4 generaters. So if I go up 2 octaves and then -4 perfect fourths, it gets me to 5/4, which is, let me put this back in. So at top tuning, it's the 5/4 is only like half a cent off. Right at
Wow.
10 Euclidean, it's still like within a cent off. The pure octave top actually puts 5/4 pure as well because it's a doubly pure thing. And
Wow.
the POTE could sit it's a bit less pure there, but you can see the numbers change as the dot moves.
Yeah. I see.
And if I put this -4 -1 here, it's
It has to be
zero. It
zero.
goes to
Yep.
zero.
Because it tempers out that comma.
Yep. So there's a lot of lines here. Like for example, here's another one. Here's Porcupine. It's got its own tempered interval. It's generators. It tunes the syntonic comma a bit sharp, like 40 cents sharp from JI. It's got its own tuning spectrum and stuff.
Yeah, it's marvelous that you
Um,
can see all this at one time. One thing I really enjoyed doing with Projective Tuning Space.com when I first discovered it was, I mean, of course, you're showing us the lines that would be in Paul Ehrlich's diagram, and there are many others that are also obvious and that are tunings that other people have studied and know about. But I love just trying to click a number and then trying to click one that's really weird and out there and trying to make a line between them. If you do that
oh yeah.
enough, you'll find temperaments that don't have names that just describe them by, I think they're crossbreeding.
Yeah. Yeah, there's some like really absurd temperaments that you can find in here.
Yeah.
Especially if you like go to really high numbers and then get something that's like super close to like mean tone or like some like
Oh no, yes.
I'm just gonna do it. Here's a cursed temperament. Let's find it.
This is great. I'm so glad that I'm getting to watch you find them because you're probably very good at finding them.
Yeah. It takes a while for these to show up, especially once it gets to be a lot of them.
Oh yeah. Wow, that's wild.
You can like once you get like these like most of these are like nobody cares about like 372 BBBCC like but you can really see like the landscape and like the gravitation of mean tone for example here is like is very prominent and
Yeah.
like it looks like everything's sloping towards it
Right. Yeah.
because it has a relatively low complexity for its area. So anyway,
Yeah.
oh no, I think I just broke it. Oh,
Whoa. All
never
white.
mind.
So the
Reboot.
yeah. Oh, this is great. So with the I guess I had been talking to Paul Ehrlich a little bit
There's
about
something.
what two did you even connect there? I just saw you clicked one. I didn't.
92cc and 88cc.
So does
I
that
just
just
clicked
mean
a couple.
you clicked 92 and 88 just really far away from each other randomly?
Yeah,
And you got that. Yeah.
I got that.
Yeah. I have been
Tempered interval is
understanding.
like that's like a whole like perfect fourth there. Like wow,
Oh gosh, I don't even. Oh, that comma is just
that comma is the size of a
that's
perfect fourth. That's
that's
incredible.
awful.
Yeah, I know. It's a terrible temperament. Delete.
That's
All right.
really funny. Um, I have been trying to understand the numbers kind of in terms of equal temperament, but also in terms of what MOSs would be created.
Okay.
Like if you have 12 and it's a large number, that means that not only can 12 tone equal temperament be a mean tone temperament, but also that mean tone 12 is an MOS that would follow that pattern. How can you've got your mapping over there and it's quite concise, and then you can also use it to find out like, how many generators would get you to such and such interval. Is there a way you can look at the MOS scale at any particular point without going into the Lumatone editor?
There's a horogram here.
Mm-hmm.
So I pulled mean tone back up. So I click this. So here it is.
And it
So
gives
this
you
is
TOP by default.
yeah, it gives you whatever you have selected here. So you can do
Oh,
like
okay.
pure octave or whatever. Oops, wrong button. Right there. Um,
Yeah.
can you hear that? Cool.
Yes.
So the generator here is a perfect fourth at 503.42 cents. And then each successive ring outward is another moment of symmetry when there
Yeah.
gets to be two step sizes for every interval class, and the generator is always going to be the same interval
Right.
class.
I see. So 14 rings. That's a lot.
Yeah, 15, I think. But
Oh,
yeah,
15. Any was what kind of consideration was put into that number? I know it's sufficient for everything, but I was wondering if there's like a logic
N-
behind it.
no.
No.
I mean,
Just
it looked
making
nice
sure.
on the screen, also like the size that I already had it going at, I think.
Yeah.
But I don't like these big numbers here. All right. So you can also, so at 500, it's much simpler.
Yeah.
This is it all crashes back in on itself at 12 tet, the
Right.
process, so it just overlaps. Like most of these are just overlapping, but you can if you change this a little bit, you can see the spectrum. You start to see this whole
Oh,
like Moss spectrum here.
this is
This is
something.
going into
Yeah. It's so different on the outer rings with so many
yeah,
notes per octave. I've seen.
yeah, here's it's around 31, I think.
Oh, okay. Yeah.
Um
And you can see when it converges on particular equal temperaments. Oh, what about that one?
yeah,
What was that one right there?
this one here.
Yeah, go
This
back.
one,
Is that? Oh gosh, is it something
that's a
like
lot.
55 or probably more?
Probably more, yeah.
Yeah.
Um I'm only going by point zero 0.01, so I'm like skipping over a bunch of stuff too implicitly. And here's something with this
Ooh.
is this like 40 or 50? No.
Uh,
1, 2, 3, 4, 5,
four.
6.
I'll bet it's 26. Yeah.
Yeah, probably. Yeah, I can keep on going. Eventually it's gonna get to 7. You can
I've
see
seen
it
this.
starting to converge into there.
Yeah, yeah. The big
So
numbers have the most
there's
gravity.
the
There it is.
yeah,
Yeah,
there's
710.
7. If
You
you
can see
keep
the
going, you
fourth is
start
really
getting into
sharp.
like the Mivilla range.
Yeah, it's
Um,
becoming like 517 cents, which is a
yeah,
really sharp
so
fourth.
you get to like a 7 and then a 9 instead of a 7 and then a 12 if you're counting the number of notes in each thing. Like that's
Yeah,
got the
yeah.
two.
This is interesting because I have used the
So
hologram,
that's
but I've never played with it this much. Now, let's stop for a sec. You just messed around on the hologram and made the fourth so sharp that it's now Movilla. So then you go back to projective tuning space, and what has happened? Are you just really, really far over on the mean tone line, essentially?
essentially, yeah, it's not
Where is it?
reflected on the app. It's not anywhere.
Oh, it's not anywhere
It's
because there's different screens. Okay, so they're not
yeah,
connected. Gotcha.
yeah, they're not. Yeah, but it would be like over here somewhere. Which all the
Off the map at
numbers
all.
on this side of it are the same numbers that are on this side of the Mavillet line here. So like 7, 23, 16, 9, 7,
Oh
23,
my.
16, 9. So
Oh, that's a new one for me. I need to recover for like 2 seconds. Okay.
okay.
Great. Okay, now
Yeah,
we're
this
back.
is all right. So this is all like the scale tree. So I should pull that up.
While you do that, I'll just mention that the only other place that you can observe a horogram's generator moving really infinitesimally and having the whole structure change because there are a lot of rings is on the Surfing the Sonic Sky website. Of course, it's not connected to projective tuning space like this is. It's just the hologram.
Yeah, I'm unable to find a scale tree on Google, unfortunately. But if you look at the scale tree, it's the same numbers.
It's the terms are adding up together and they're nested.
Yes, yes. So this is very zoomed out here, but
Can you zoom in at
down.
all with the
Yeah,
mouse?
let's
I think
see.
that might work.
Yeah.
Yay, great.
All right.
And
So
now what we're looking at, everyone,
three or
is the
four.
scale tree created by Irv Wilson in 1994. I guess it has a little copyright symbol by it. That's kind of wild.
Yeah, there's a lot of copyright symbols on this stuff.
Hmm.
Anyway, so here's 3 out of 5, and then here's 4 out of 7. And then in the middle of that, 7 out of 12. If you continue, then you can get to something with 19 in between these ones. You get something with 17 in between these ones, and 22 there. There's a 31 down in here. So this is the Mavilla side. Mean tone is in like this little branch here, and then super Pyth is like over on the side here. And you can extend this process down infinitely. But the
Right.
numbers here are all the same that are on the scale tree.
Yeah.
On the here, super Pyth up here, it's got the same numbers, 17, 22, 27. Like all of these are just branches and bits and pieces of the same scale tree everywhere.
Right. I
Just
see.
crossing.
Yeah.
Sometimes it's like multiples of it, like augmented here, everything's times three, but it's like still within the same scale tree.
Yes. That makes sense. I guess your revelation about flipping the numbers over makes me wonder about like how if we were using a mean tone temperament, for example,
Mhm.
another distinction that might be good to make is that you could go along the mean tone line and mathematically anything there could be a mean tone. But according to the conventions of like what a mean tone temperament will accomplish, generally the things that work out best as a temperament that would make intervals equal other ones that you would think
Mhm.
about normally would be in that denser area with all the numbers and not in
It
the
would
sparser area on the outside where the values are really far from their just analogs.
Yeah, well, the density is relation to how they're populated. Like theoretically, the numbers are everywhere, but they're just like ruler points, basically. Whatever's closest to the just intonation point is going to have the best mean tones. And so basically, the more the generator is nestled within the boundaries of these larger numbers here, is going to be where your good mean tones are. So like 31, great mean tone. Everyone loves 31. 19 and 12 are also good mean tones. And then like as you get further out, on the other side of 19, there's some values, some stuff that gets flipped over, certain commas and stuff gets flipped over, but you can still get like mean tone 26 and then
Yeah,
like 33, 40. These start getting into like the deep tone region, which is the 5 kind of moves up by a apotemy
right. It's
into
getting like
these.
really, the major third is getting really flat, as is the fifth.
Yeah, yeah, such that 5/4 is like not even that anymore, and it's a different note.
Right. Yeah. I actually had a temperament question because
Yeah, okay.
what I've been using for the popular like kind of temperament narrative, right, is the idea that if you add up some amount of intervals and then you have it be equal to something else, like in JI, those two additions will end up being different if you're tuning purely and actually ending up on different notes. But then in a temperament, they could end up being the same. So
Yeah.
I've been kind of using that for a metric as to whether a temperament works, even though I know it's not perfect. And sometimes it's imperfect. And I naturally found a circumstance in which it was. I don't know if you're familiar with the schisma, um,
Mm-hmm.
but I was exploring something where I tempered out the schisma into a rank 2 temperament. I actually am not sure how to find it on there. I don't know which line it
It's
is. Is
this
it
one.
Helmholtz? It's that one.
Yeah.
Okay, gotcha. Okay, well, I realized on the temperament finder it gave me 12 and 53, and I found that 41 and 29 also worked. So I see them on that
Yes.
line there. And 17 should be somewhere else too,
Yeah,
really far out, right?
17p is yeah out here.
Okay. 17p. Yeah, okay, that does work. Okay, then 17
Yeah.
technically is a schismic temperament, I think. But
Yes.
it's so
It's at the far extremities of it
right, the
to
reason
the
it's
point
so
where like prime
yeah,
5 is like almost just like dissolved into nothing.
because I want to do schism by tool, but just in schismic, schism in schismic,
Yes.
which is very silly. We've already done Godzilla in Godzilla, so that's the next one. And so then I was like, well, this isn't a Zen move, right? Like if you make a Pythagorean diminished fourth the same as a major third, it's really hard to make that Zen on its own, I think. Just because 12, in a sense, already kind of does it. But I think you can make it Zen in 17 just because it's so deformed.
Just make sure you use the neutral third as your major and minor thirds.
Right.
I don't know how that would like affect it. Technically, this one, 17p, the 5 over 4 is like 33.3 cents flat. And then in
Right.
17c, it's 37.21 cents flat. So, like,
Yeah.
or sharp, sorry. So, like, this one is clearly worse. But no.
Yes. But they're both
This one
so
actually makes more
apparent.
sense. It's actually a bit closer to the just intonation points overall.
Oh,
This
yeah.
one's out here. This one's look a little bit further out. Um, this one's it's more consistent. It's consistently tuned because here prime 5 because it's like right here on the Sticot line, like prime 5 is like very quickly subsumed by 3 because
Yes.
like emit just 2/3. It's the fifth, the 5 over 4 5 limit intervals are just like half of a fifth, half of a
Right.
5 over 3 over 2. I hate
Dicot.
those numbers. I hate those numbers so much. The fifth and the third, they're flipped around from what they mean harmonically and
Yeah,
scale wise.
it's
It's dumb.
terrible. Harry
It's
Parch was
terrible.
right. Just awful. Okay, so we've been looking at 235 projective tuning space, and if there's a favorite temperament that you didn't get to see on here or that you didn't see us click, we highly recommend you explore it yourself and see if you can find it. For example, the classic horizontal lines being blackwood and whitewood at the top and bottom. I love those. Yeah, click those. Ah, there we go. There's blackwood, and then whitewood,
There's
named after
Whitewood.
blackwood. 5 ends and 7 ends, respectively, which will give you certain multi MOS scales. Now, Chris, I'm wondering if we can look at a projective tuning space that doesn't use primes 2, 3, or 5. Do you have any recommendations for which one we should look at next?
All
Yeah.
right. So here's 357. So 13 is super close to the middle and it's pretty prominent. And then along this line here, I can hit map merge and there's lambda here. So this is 245 over 243, which is like the sense of magic, Bowen Pierce comma, and 13 is very good for that. And there's other stuff as well.
Yeah, yeah.
A lot of other um,
It's so interesting to think about how these other temperaments might work because
serious.
now none of these temperaments will have an octave, or at least we're not thinking about it in an octave equivalent way, but you could get things that are mapped to something really close to an octave. It's just that prime 2 isn't being considered.
Yeah, prime. Yeah,
That's great. But yeah, of course, these are these are more obscure temperaments, so it probably would be easier to find one without a name, but I'll bet you're really familiar with the names of these because you're essentially adding these by hand, right? Just based on your own knowledge in the Zen Harmonic
A
Wiki.
lot of these, yeah. I wrote a thing to take all the temperaments from the temperament finder,
Oh,
but then
yeah.
there's like a lot more that aren't in that
Hmm.
that I had to add all this by hand. So
It's kind of like the Wild West because people are just naming things left and right.
yeah,
Yeah,
yeah.
absolutely.
I added a thing for other people to add names also. I have to go through and like make sure they're good names.
Yeah, you have to like give
But
the stamp of approval and everything.
yeah,
It's great.
I don't
Um,
want somebody naming it like drop tables or whatever.
right. I wonder. So this is 357 space, and you're
Mhm.
dividing three, the third harmonic. I wonder also if the order in which you type the primes changes the diagram, or whether they're automatically sorted from lowest to highest. Could you have a
It does
situation?
change it.
Okay, so you couldn't have a situation like 537 where it would divide five instead.
You could. You can also just change like what it's showing. So right now it's showing like whatever's the mapping for three, and then
Yeah.
there's the mappings for five, and then that's for seven.
Oh, okay.
That's
So
for
you can change
everything.
that. So you can change that over there,
There's the
but then
EDOs.
the space will always be organized in terms of just primes in order.
Yeah,
I
but
get
you
it.
can
Okay.
also do it this way, and it's like this now, and it's different, but it's like
Wow.
mostly just like rotated or reoriented. So if I change it to the Z, which is the three value, there's 13 still
There's
there.
13's back. Yeah.
This line here is still lambda or probably lambda. The order is
Lambda with
weird.
a question mark.
Yeah, it's the same comma, same ratio, different
Yeah.
different notation. But
I love it. That's cool. The Bolin Pierce scale is 13 equal divisions of the tritave, so it makes sense that 13 is big and in the center since it's so good at tempering 3, 5, and 7. Okay, cool. Can we look at one more? Maybe one with 2 in it. But that ooh, maybe could we do like 2, 11, 13 or something?
oh yeah, that's a good one.
Yeah.
2, 11, 13. Let's change
Wow,
that. All right.
wee.
So it's 2, 11, 13. It's got some stuff here. So it's got I think this one's Lovecraft here.
Ooh.
Um Bluebirds here, which is like the other side of Tetracot. This is like neighbors with Tetracot on the scale tree. Tetracot is like
Oh, you actually
down
know
in
about these.
this
That's incredible.
range.
Yeah.
Yeah, I like Bluebirds quite a bit actually. It's well not very well known, but I think it's
Yeah.
nice.
That's neat.
And it works with 33 EDO, which is it's fun.
Amazing. Yeah. That's
But
really
yeah,
cool.
Tetracot would be like in here, there's the 27, 34, 41. Down
Yeah.
here on the other side is like this is where the porcupine type stuff is here with 22, 15, 7, 8.
It's
But
really
this
interesting
is
that it's so
so you see
far
like the same
out
sequence of numbers.
just
Yeah.
in different places. Yeah.
Yeah, like the five limit stuff is like kind of wild and inconsistent in this area, but like the 2, 11, 13, it's pretty good.
And you could use any
What
primes
else we
that
got?
you could use any primes that you want to
Blackbirds.
generate that space, or can you also use odd numbers?
You can use like just about any number.
Wow, that's really crazy to think about.
Yeah. Although it gets kind of weird sometimes, like if I do like 2, 3, 9,
Yeah, let's
you actually do get one that goes directly through the just intonation point,
right
and
because of the
that
redundancy.
tempers out. Yeah, it tempers out like 9 over 9,
Right. I see. Okay.
which means this entire axis is like half meaningless, but you do kind of like see some of the split 3 action going on some of these. But
Oh,
it's much better if you just use like prime numbers. But also speaking of prime numbers, there's you can use feudal primes. I added that in also. So like if I put F1, that's gonna be phi, and then like F5, F11, which is like the small root of 11. So like 6 ED phi is
wait, what are
like
the
a
Fs?
pretty feudal feudal numbers.
Feudal numbers?
Did you see that thing that Dave Keenan put together with like that really complex looking diagram with a bunch of blue dots and a few red dots and some empty spaces
I did
and
not see that. Please enlighten me.
oh gosh, it's basically you can like take prime factors, prime ratios of you can factor primes. Certain primes are actually like can become more prime if you use phi as a prime. So this thing here, this is really complex. But
Yeah,
these
I
are
was
all
about to
prime
say I
numbers
don't
here.
think okay, so the red ones are
The red ones
phi's
are
at
like
certain
units,
degrees,
phis and ones,
phi's and
and then
ones,
yeah, so like this times
and then the blue
itself
ones are
equals
the normal
5.
primes.
These are like normal primes here, and then these are yeah, it's really
So
um
it's a graph showing how you could multiply phi's and primes together, or like
yeah, if you use phi as a prime, phi squared equals 1 plus phi.
yeah.
And that's because of that, these numbers end up being basically prime, and such that you can have like 5 is no longer a prime number, 11 is no longer prime
Oh,
because
I see. If you
this
pretend that,
times
yeah,
this equals 11. So
right,
like these are primes, 11's not a prime
right, okay,
but it's also using like the golden ratio, which is like the some say the worst sounding musical interval of all. So
yeah, baby.
yeah.
Oh, that's so cool. So that I guess then those primes that were to the right in uh blue dots were fundamental primes, and those are primes that you can't get to even by using phi.
Yes.
Oh wow, that's so cool. So I guess they're sort of on a whole nother level, huh? Wow.
Yeah, this is another level, I guess.
So then the F's that you're
But
typing in are referring to some of
theirs
those.
are these Fs. I just copied them in and I said, if you type an F here, it'll put this number. And then
Wow.
I clicked go, and this is
Oh
what you
my
get.
gosh. So this is really a lot. Let's see. I don't even know what value F1 is. Can we try and
S
figure out the
phi. F1 is
values?
just phi.
Oh, F1 is just phi. Okay.
Yeah,
And I don't know
F1
how big
there.
phi is offhand either.
1.618,
Oh, okay.
which is about like 833 cents.
Oh, I see. Yeah, that's a pretty out there interval.
Yeah, you can also do like EDOs with it. It's like 2 F1 and then like
Yeah,
square root of 5. F5 is just the square root of 5, so
you could just combine them,
13
yeah.
EDO is pretty good for that.
Yeah.
Yeah.
That's insane. Just the capability. Well,
Yeah, I
thanks.
usually just use like the prime numbers though, regular
Yeah.
primes, because they're easier to comprehend.
Yeah, they really are. It's just so much easier to do stuff there.
Can I show one more thing?
Yeah, sure.
Okay. So for example here, let's look at this whitewood comma, which is the apotemy. All of these
Yeah.
numbers, everything, everywhere besides here is tempered in some way. Along these axes, it's like not quite as tempered, but we can look at how if I go down here and if I put this comma into this rainbow interval here, it's going to color all the numbers according to that. So um, minus 1170. So along this line here, all these numbers are black, which means it's tempered out. And then anywhere that it's
Oh,
kind of orange or red, it's tuned to like a positive number. Over here, this is like tuned pretty justly at this orange here. And then over here, it's tuned even sharper and sharper. Down here, it's below this line, it's tuned negatively. So, like for example,
wow.
anywhere on Mavilla line, this whitewood comma epitome is going to be tuned negatively. Then this whitewood in the classical music sense of sharp and flat, this interval is what constitutes a sharp or a flat,
Yes.
which is why, depending on how you look at Mavilla, like sharps will actually lower the pitch and flats will raise the pitch if you go
Yeah.
along the circle of fifths of that. And likewise, all the other lines here, any point closer to that, to the just intonation point than to where the temper dot comma is going to tune that line, tune that interval sharply or positively, I should say. And then any point behind it is going to tune that interval negatively.
Wow.
So like
This is such a
as
great
you
comparison to be able to make.
Yeah, so like for like what we were doing earlier, like moving along this line, like as you cross over certain boundaries, certain numbers, certain intervals will flip over. So like if you go below 19, like this, everything that's tempered out in 19 will be flipped over to the opposite way that it was like in 31, that it is in 26, even though your mean tone both ways, the other commas that are tempered out in 19 are like tuned oppositely.
So I guess and on whitewood, if you're comparing to whitewood, you've got like a horizontal line,
Hmm.
and so there's up and down. Let's say you're using the rainbow interval comparison for another temperament line. Are you
Okay.
still going to get a color gradation that's exactly well, you'll still get a color gradation that's smooth, right? But it won't be
Yes.
gradated. It won't always be gradated in the same direction, essentially.
It's It's graded it in the red, orange, yellow direction towards just intonation, and it's graded it in the like magenta, purple, the other side of the rainbow in the negative direction.
Right. Okay, I see. Oh, that's really cool. That's insane. Is that a new feature?
No.
Oh, okay. I just didn't know about it. There's
Yeah, it's buried in here, I guess.
there's so much in here I don't know about. No, that's
All right,
okay.
let's pull up mean tone here. I'm gonna put this back to regular. All right, so mean tone. So let's do a 31 EDO, and I can pulls it up here. So I check 31 and then I click 7 for the albatonic scale size. And that means I'm going to have 7 notes going across and then 31 total in a mean
Yeah.
tone arrangement. And if I click connect to Lumatone here, I'll have to make sure it's disconnected from my other ones first because Microsoft hates MIDI. I hit connect, it's going to create and it's going to populate it on my Lumatone down there.
Yeehaw! And you can just plug your Lumitone into the computer and put all of that together, and it's all there for you.
Yes.
Incredible.
So let's see. Um, Connect it to here. So I got 31 EDO in here. So you can also you can show here's the period and generator counts for how to get to each note according to the what's here.
Yeah.
So this is 4/3 to there to there. It's an octave. Here's 5/3. So if you go up 1, 2, 3, 1, 2, 3, and you can bring this down 2 octaves. That's going to be the 5/4.
Yeah.
But you can pull these up for like anything, any temperament. So
That's so
let's do
neat.
another one. Do you have
Yeah. Oh
any
yeah.
choices?
Okay. Yeah.
Anything
I
you
was
want to
about to
choose?
say
Let me
I
pick.
gotta give you a good request. That I wouldn't know how to do, but you would. Um, that I also still know as a scale somehow. Um, let's do. Oh, have you heard of the vulture comma?
Vulture. Yeah, what? Yeah.
Let me see if I can find it. If we can do it,
Is
that'll
that
be
in
good.
like a thing with three prime numbers? I
Oh, I hope so. I'm pretty sure it's a seven
think it
limit
is.
comma. I'm gonna search for it right
All right.
now because I was wondering. There's some commas where I don't know what MOS it is offhand. I can tell you the Monzo. Would that get you there?
Yeah.
The Monzo is 24 negative 21 4,
Is that
and it
in five limit?
actually yeah, it's actually just five limit. Just kidding.
All right. 24. Just 20. You say what do you say? 24
Yeah, 24 negative 21 and
negative
4. It
negative
was
21 4.
it's one I just randomly found
There it
one day.
is. Vulture.
Whoa, sick. Okay.
All right, let's
Let's
go.
see.
Let's 53.
And then let's do
And then
13 or 8.
13. All
Yeah.
right. So
Hey,
there's a lot
sweet.
of all right. So there we go.
Yeah, 13's a little harder.
Now we're now we're in Vulture
Now, I
13.
Now you've also got the
So
color
I have
scheme
to
there.
change this to 53.
Oh yeah, you always just got to change
There
it
you
to
go.
the equal temperament, and then it'll work. Yeah,
Yeah. Although in theory, like it works with like anything, any kind of ultra that's with the 53 ton moss.
yeah, yeah. The ooh, looks like it has some really small steps.
Yeah, it's got just one going horizontally. Let's see. So
Oh, that's really weird.
yeah,
Oh,
this is what
that's
the moss of it is.
oh that small step for you is horizontal.
Yeah,
Oh
because it's
gosh.
13.
And then that down right step is like a whole step or something, or a large whole
And
step.
that's 9 and 1. Oh well. If I pull it back to let's try 8. That's 10 and 1. Yeah, vultures. That's oops. If I did 5, I do 5. I'm not gonna have very many notes. And that puts the 1 on that side. Yeah, vulture's kind of sharp. All
Yeah, it's
right,
weird.
back to 13.
That's why I was wondering what it would do, because I was like, I haven't heard any MOS happen here. It sounds really 5-tet like 5-tet with
It is.
microtones. Yeah,
Yeah, this is the moss of it. So there's like the 5 is very prominent in it, and also it's like 5 is by far the smallest number that's like anywhere close to where we're at on this line.
right. Yeah,
So it has a very strong influence.
that's very cool. Yeah. Now I wanted to comment a little bit on the color scheme. I know
Hmm.
that you've got some kind of program that decides that. We had talked about it a little bit earlier, but the what I was wondering is if you have so you choose scale sizes by choosing the equal temperament and then choosing the MOS size scale that's a subset of it that you want to see reflected on the keys. The way you know that MOS size is by seeing that there's one continuous color throughout the middle that has that MOS size, right? That's essentially how you
Yeah.
know. Yeah, yeah. Okay, that's great.
Or-
And then it lines it up in
Oh,
order and everything for you.
the way the colors, it's just going like it's counting up the generator steps, and then like it just clusters them into groups of um either the size of the albotonic size that you chose,
Yeah.
or the difference between that and the next highest size of scale.
I've got another temperament that I'd love to see that I discovered once. Like, because
Okay.
some temperaments I just discovered because I want to temper out the comma, and then I never figure out their MOS scale.
Mhm.
So I'd love to do Lasonic next. Um,
Sonic, what's
yeah,
is that 5 limit?
yeah, it's 5 limit, and it tempers out.
Or do you have the ratio?
Yeah, 2187 over 2000. Oh, you can just type in the ratio, duh, because your website does
Or
everything.
2000. Oh, yeah, laconic.
You thought of everything. Laconic.
Yeah.
I guess I've been calling it
Yeah.
Lasonic. Okay.
I don't know. Maybe it's supposed to be Lasonic. I don't
Well, let's do 37
know.
tet
Yeah.
or a generator near there, and then whatever MOS you'd like to play on.
Okay.
Yay.
37. And then let's do 6. All
Oh,
right.
oh my. It's so cool how it changes the notes on your Lumatone one at a time, but it doesn't do it in a big swath. It does it kind of like in what seems like a random order. Did you
It is
program that?
random order.
It is random.
Yeah.
Yeah, that's great.
Yeah, I had it as a swath first, and like it's more exciting to watch it do the random
Yeah,
because it takes a little bit for it to go through it all of it, and you have to do it one at a time, I
right.
think.
Yeah.
So it's more fun that way. All right, 37.
It also sounds like 510.
It's pretty small.
Oh yeah, it's a bit on the flatter side there. Apparently, it tempers out the difference between like a stack of three whole tones and a perfect fifth. So it's kind of a high error temperament. And I
Yeah,
found it.
uh, it's kind of related to Slendrick in a way, but go ahead.
Oh, I had initially found it because it does some chord progression in 16 that worked out. Like I was doing some cover song when I was in college, and I made the chord progression drift so that like a B chord equal to C chord, and then figured out this temperament as a result.
Ah, cool.
which is kind of neat. But yeah, yeah, it does sound really Slendrick. Those fifths. Yeah. Wow.
Yeah,
It's
it's got
so.
the because Cylindric has 8/7 equaling like a third of a fifth, and
Yes.
so
Yeah.
the
Yeah.
Cylindric is optimized more towards like the 31 side of it. But if you go into the 5, 2, 3, 7, you see the same sequence of numbers here.
Yeah.
So this is where we were on the laconic here,
Ah.
down
Yeah.
here
And you could
between
just find
21
the
and
same
16
spots.
here.
Yeah.
And but if you do 7 instead of 5, like it pulls like way over here, much
Right.
purer by the 36, 41.
Right. Because now we're evaluating it in terms of seven limit instead of five limit, and so it gives you pure
Yes.
seven limit stuff than
And
five
we're
limit
not
stuff.
even caring about 5 right now. So
Yeah.
if
Great.
we if it for a full 7 limit, it'd probably like be close to 31 or something, but I don't know. I
But
guess it
yeah,
depends on like what the 5 you do.
this is such cool stuff. So I see also that you've got like when you click on a temperament in the window where you have the tempered interval size and other
Hmm.
things, you've also got some buttons that take you to other sites. And I assume that those buttons take whatever temperament you have and like put it in that site. Like if you click ZenWiki, you would go to Slendrick on the ZenWiki. If you go to Scale Workshop, it generates the scale for you in Scale Workshop. Essentially, is that right?
Yeah, you choose
Wow.
the size of it, but
Yeah,
like
because
it'll
since you
pull
have
it
to
up.
generate a fixed scale, that's
It's
so cool.
I don't have
Wow.
it letting you select the precise mouse yet, but it's
I'm really impressed how fluidly this projective tuning space.com connects to like everything essentially. Oh, and I forgot that ZenCalc existed. Someone
no.
showed me that it deals with gives you a Monzo the other day, and I forgot that I could use that as a tool. I've just been googling things on the ZenWiki, but that looks better. So
Yeah.
yeah. But yeah, I also use this for my Lumatone layouts because I think when the Lumatone first came out, people were writing lots of different pieces of code to generate layouts, and some of
Hmm.
them are really effective, and I used them in the past and or got layouts from other people instead of making them from scratch. But I'd say Projective Tuning Space is probably the best way to generate a layout right now. Also because it has its own unique color scheme, and you can connect it to any temperament you want, and not just equal temperament, which I think is something that is really really useful.
Yeah,
Another
thanks that yeah, I started I wasn't even intending to like have that as part of hits this, but I just got tired of spending like an hour like fiddling with the Lumatone software to make a layout, and so I just decided to like make a thing that makes layouts for me, and here it is.
I think the next dream that people have is to connect dynamic tonality or the idea of retuning your scale on the fly to projective tuning space and maybe the Lumatone in a way that is visual. Um, I certainly envision something in my head of like a ball moving across one of the lines and the music accurately reflecting that generator change in real time.
Yes,
And maybe while you're playing the Lumatone, the colors are also changing over time.
that'd be super cool. I also have that idea, and like you could like change directions and go along different. You could like go to an equal temperament and then pivot and like go along a different temporary interval and like explore all over the place in like one song or piece of
Gosh, that
music.
would be so cool. Yeah, what you could do with that if you had the right equipment. It's definitely a dream. Well, hey, thanks for
So
taking us on the tour. I feel like we've gotten a pretty definitive tour of Projective Tuning Space, so I encourage all of you out there listening to play with it on your own. And yeah, it really rocked the Un-12 boat, I think, when you presented on it.
thanks. I also want to show this equivalence continuum here. There's a
Yeah,
bunch of them. They can see them on the Zen wiki, but here's the
absolutely.
syntonic chromatic or something continuous continuum. So we're going to look at syntonic commas and apotomies. So how many syntonic commas are going to be equal to one apotomy?
I forgot about this.
So,
Yes.
so like if I hit subtract and then subtract this, it'll put another one here. So in Mavilla temperaments, whitewood or the apotomy and syntonic comma are the same. One equals
Yeah.
one. If I subtract another mean tone comma from here, dicot, one apotomy equals two syntonic commas. And then if I do another one, we get to porcupine. where 1 equals 3 syntonic commas. And you can just keep on going like that. And
Yes.
um, yeah, it just keeps on going. You can like load these up in the Lumatone and see that it's does that and stuff. Can I
Can
show you one more thing?
Yeah, absolutely. Please do.
Okay. I figured this out like a month ago. This is not on the website yet, but so here I rigged this up in Blender. So this is just a lattice here.
Yeah.
So on this horizontal, this green is 5, and then or green is 3, and the red is 5 on the vertical, and then on this depth one is 2. There's a
Right.
blue.
Yeah.
So 2, 3, 5. So some of these have dots, colored dots. So for example, these yellow dots here, there's a yellow dot
Right.
here, and then a yellow dot over here.
Yeah.
So if I want to go from this yellow dot to this yellow dot, I got to go minus 1, 2, 3, 4 along the 2 axis, and then plus 1, 2, 3, 4 along the 3 axis, and then minus 1 on the 5 axis. So this is a 81 over 80 syntonic comma apart,
Right.
these 2 points. So if I project it in an orthographic projection like this, so all the parallel lines remain parallel,
Yes.
and then swing it around here so that these 2 dots go right on top of each other.
Oh, right. Yeah.
So just like that. And this is a lattice of mean tone temperament now. You can see this 5 over 1 is divided into 4 equal sections. This 3 over 2 is 1/4 of the 5 over 1 in mean tone. And you can
Wow.
see like 9 over 8 is here.
Yeah.
5 times 2 is 10 over 9 is the same point. And
That's so cool.
so yeah, that's basically how the projection works. It's like really central to the whole thing, I think, of
Looking at things at an
temperament.
angle such that everything that you want to become the same becomes the same.
Yeah, and then you
Yeah.
can see like all the everything else that goes to that. I got a whole bunch of them. You don't have to go over all of them. Let's see, here's this porcupine there.
Have you've seen that done in a Tonescape? It's not the same as what you're doing, but
Yeah, I had trouble getting that software to run.
yeah, that's really incredible.
Here's Blackwood here. Blackwood has the 5 is completely independent, so it just
Yeah, I
goes like that.
see. Right, you just have
The
those red
2 is
lines.
divided into 5 parts. The 3 is divided into 8 parts of the same. So
Yeah.
it's
Oh, can you do a
yeah.
Mavilla?
Yeah, I got let's see, that's the brown dots, I think is Mavilla
Oh, okay. So you want
right
the brown
there.
dots on top of each other.
Yeah, so um yeah, here's Mavilla. So let's see. 1, 2, 3 over so 4. I, I'm lost. Sorry.
Oh, you're okay.
Yeah, this is Mavilla here. Um
Oh, you already got it.
yeah.
Oh, okay.
Yeah, I'm trying to remember the Mavilla thing, but
Right. I don't know the
yeah,
Monzo
3.
offhand.
And then there's the one, yeah, 3, 4 over 3s, the 5 over 1. It goes. It always like forms a triangle that um outlines the Monzo whenever you project it like this. You can draw a triangle
Oh.
around the Monzo.
Oh, okay. Are there any plans to incorporate that into Projective Tuning Space, or is it just another thing you're working on
Yeah,
there?
I'd like to at some point. Yeah,
That'd be great. Yeah,
this
that's so
is
cool. What you're doing.
something I just figured out very recently.
Yeah, that's amazing. I love it. I feel like that could be a really good teaching tool because it's so hard. Sometimes it's really hard to tell people to visualize things a certain way, and you have no like animation to do that with, and so you just have to hope that they
Yeah.
have that imagination. Well, it's been great talking to you today, Chris, and we will definitely schedule another call to talk about your instruments.
Okay.
So for now, I'll
Sounds
have to
great.
say ta ta. As you might be able to hear, this podcast was split into two calls. The first call being about projective tuning space, and the second call being about instruments. So without further ado, Here is the start of the second call, where we talk about Chris's instruments. Okay, thanks for waiting now, Zen fans. We're back with Chris Kline for part two, instrument exploration. Thanks for being on with us, Chris.
Thank you. Thanks for having me.
Yeah, of course. So, of course, when I met you at camp for the second time, actually, because we had done Mrs. Robinson a little bit earlier, you showed us a lot of 3D printed instruments. So I'd love to hear your process for how you came to realize that that was a way to create them and how you decided which instruments to then print.
Well, the first ones I did was the ukuleles, which I need to get up and go get one. I have five of them right now, actually, in 15, 16, 17, 19, and 22 EDO. So,
That's more than you
which
had
one?
before.
It is. Yeah, it is.
What?
I'm gonna grab one of them because if I drop it, it might break, and then I have to print a new one.
Okay.
So that's happened before. But
Okay.
yeah, which one? Which one do you want?
Gosh, that's such a great question. I guess 15
15. All
to
right,
make
I'll go
it
get it.
easiest for you.
All right. So here's the 15 EDO one. It's got the
Wow.
frets all printed in place there. 15 of them. It says 15 EDO.
For those of you listening with audio only, first of all, you should try the video on this one. Secondly, it says 15 EDO on the fretboard right at the end, right where the fretboard runs out of frets close to the center of the sound hole.
I've got it tuned to standard tuning, which is
What would you do for
fourths,
that?
and the diatonic third, which in 15 is also the same as a fourth. So it's really isomorphic on the 15 one. Yeah.
GCEA is the normal one. So then in 15, you have 15's version of G, C, and then for the E, do
E,
you
A.
have something that's a fourth higher than the C? And then A that is like a another fourth higher than that, or
Well, B and C are the same in 15, and E and F are the same. So I just call it
yep,
Beast and F, Ef, Beast and Ef, because they're
B,
just
C,
one
E.
note. Yeah. A, B, C, D, Ef, and G are the pentatonic. Um,
And A is the same as B flat. So does that mean that so
yeah.
your open strings are a stack of fourths then, and not like a third and then another fourth on top of that?
Yeah. Yes, because you can call it a diatonic third, but the diatonic in 15 is just the same as in five, and the third is the same as the fourth because it's the farther thing. But
Right. It's a very weird
yeah.
equivalence. I've been
And also
calling
the
that.
top string on ukulele is an octave up, so
Yeah. What does that do to chord shapes? I'm so curious.
it makes things like smushed that way more, like that down here. So like a D major, for example, is like right here.
I see. And you have to use an extra finger instead of doing
Yeah,
the
it's
shape
kind
where
of
you're
like
all.
the same with the super pi type fingerings. It's similar to that, and it's got the like the Archie thing with the super accessible sevenths.
Yes.
Also, like just two fourths away, especially on 15 because it's all fourths. Yeah, I found a model online for a 3D printable ukulele. And so I looked at it, I opened it up in Blender, the 3D modeling software, and just took like the polygons for the frets, and then opened up a FretFi into 2D web application, which I can share on my screen here actually.
I love Fret Find 2D. It saved my life so many times.
Yeah, this website here, you just put in like how long your thing is, and like how many frets you want, and it'll just like put you bunch of numbers. So then I just copied and pasted these numbers into Blender and put the frets in the spots and printed it out. Basically, that's pretty much it.
Yeah. That's incredible.
So like it's if you can make like a 12 tone guitar or ukulele or anything, you can make a microtonal one just as easily. It's not actually hard and the math is already solved. You just go on this website and it does it for you.
And it's very precise too. Like I know that when I've used it, you'd think that the fret lengths are exactly the same on each string, and they
Mhm.
are really close, but they're infinitesimally different because of the
Yeah,
angle that the
because it
string
fans
makes,
out slightly
and it
as it goes
calculates
towards the
that.
bridge. Yeah.
Yeah, and it doesn't do it the same for every single one like some other places might do or might assume. So it's really quite good.
Yeah. I just copied and pasted just like the central point. I didn't go in that in depth with my 3D prints, but
How difficult is it to make Blender agree with 3D printing software. Is it like you would make some kind of Blender
It's
file and then a 3D printing software would accept it?
you just save it as export it as an STL file and then just load that up into your 3D printer slicer and it'll send it to the printer and print it off.
That's amazing. Do you have some other 3D printed instruments to show us as well, other than the
I
15?
do. I have some flutes here. This is a 10 EDO. This is the first flute I printed. Um, and that's a the neutral scale from 10 EDO, or it probably goes by many names, but it's the like the
Die Cut
neutral
7.
seven. Yeah, yeah, dicot, um, Timif, or whatever you want to call it.
Mosh.
Yeah.
I promise we're not just making up names, people. These
No,
are
somebody else
real.
already made
It's true.
up these
Somebody
names,
else did
so we're just
it.
rolling with it.
That's
Yeah, this
great.
is the scale that Elaine Walker uses in a few of her tracks.
There's some tuning systems where they're so large that there's quite a few albitonic scales or white key quote
Hmm.
unquote scales, if you're referring to the piano, that I could pick to be the main mode of this tuning. But in 10, it really is unambiguously the Dicot 7 mode or that whatever mode that Chris played, whatever you want to
Yeah,
call it. And there's just really no other good ones, and that's just the one, which is so strange. That flute has a lot of holes for
it's
10
got
EDO.
the number of holes minus one of the pitches. So I mean, you just like release holes going up the scale. You can overblow it to like hit the second harmonic or third, fourth,
I
etc.
see. Does that mean that the ranges of them are usually an octave plus whatever overblowing you have, and then you can also half
Yes,
hole for more chromatic pitches too?
yes.
If you were trying to create ranges that were more than an octave, what would you do for that? Or is that not really practical with that kind of 3D printed plastic flute?
You can do it. There's a website called Plutomat that will just do all this for you.
So Flutomat is like Fret Find 2D, but for flutes.
Yeah, and it automatically generates the 3D model. So
Right,
you just
yes.
just go straight to the printer.
Yeah.
Um,
That's great. And my understanding with the flutes, of course, is that like the physics of it are way harder. So like on a guitar, where it's like if you're here on the string, if you're 4/5 of the way through, that might be a 5/4 somewhere. That like kind of makes sense. But then with the flutomat, it's like the holes all like they multiply in a really complicated way, and it's like you couldn't parse that
yeah,
yourself.
I don't know how all that math works. I can show you this website here.
Yeah, sure.
So it's just this Flutomat website here. You just put your scale in here that you want. So whatever you set to 0 cents here is going to come out as this, whatever's on the key. So I just put my end of flute at 0 cents, and then
Yeah.
you just like open up like Scale Workshop or whatever, and like make a scale. Just do. I'll just do the one that we already had.
Oh,
So
nice.
here we go. That's basically it here. It might be a different mode, but
Chris,
um,
by the way, is selecting the 3L4S scale, which is the like MOS name of the scale we just talked about in 10 tone equal temperament. And generally, actually, this is funny. Some scales, people can't decide what mode they want to play, so they might pick brightest. I feel like in 3L4S, people almost always pick the mode that starts with S and then goes LS enough times until there's an S at the end, so that the S's are only right next to each other around the first note that's played.
I think I have the one with two S's at the beginning on this loop.
Oh, you do?
Yeah, I do.
Yeah,
Hmm,
yeah, yeah. Interesting.
cool. I don't remember why, but yeah. Anyway, you go over here to this analysis tab, and it'll if you hit cents here, it'll always give you the cents. Sometimes you might end up with like ratios and stuff. But yeah, you just copy these, just copy it, put it here.
You copy the sense.
Yeah. Although this is a 8 tone flute here. We want the number of holes plus one is going to be the number of tones. So if you want a 7 tone flute, we got 6 holes, and we just copy it. These are easy enough to type, but sometimes you get like a bunch of weird decimal points in the numbers for like things that are not easily divisible by 12 or factors of 12. So
Yeah, this is
yeah, once you just copy all this in here and 720, 840, 1080, like that. And then you
sync it
got to
up.
mess with these like hole sizing a little bit. You
Yeah.
got to like make it like bigger, smaller in order to get them.
So if you mess with the hole size, The
So
other holes
that's
readjust. Yeah, that wouldn't work
yeah,
because the holes
so
are overlapping.
yeah, so you have to like adjust it a little bit and like get things to like the right spots and stuff. I'm not going to go all the way in depth, but like once you have it looking ergonomic and then you just hit 3D right here, it'll like load it up and then you just generate STL, download it, and you just print it out.
That's incredible. That's such a short process. You didn't even need Blender for that one. You just
I
had
didn't even need
Flutomat.
Blender.
Yeah.
On some of the larger scale ones, like my like 15 ton one that has Blackwood 10 in it, and I had to have like a 10 holes or nine
Okay.
holes on it. Like one of the holes, I had to like open up Blender and like scoot it around, like twist it around to be on the like a thumb hole on the underneath.
So if
But
you have a lot of
yeah,
holes, you
for
just
the
hit.
most part, like you just download it and print it out, and any flute you want, pretty much. And if you put you can put like bigger things on there too.
Yeah.
Yeah, so if you like 19-20 cent interval, it'll be like way up here. The hole's like way up there, but it'll work. So I
Yeah.
had a bow and Pierce flute that went all the way up to the tritave, even though like it'll still overblow at the octave. So don't do that. That's not allowed to bow and Pierce. But
Right.
yeah.
So that's interesting. I guess
So
if you
yeah, and also like the overall length of the flutes. Like if you have negative cents, it'll make it a longer flute,
ah,
pretty much. But
I see.
all my flutes are this length because I set them all to C.
So if you have a lot of holes, then it's tricky to not only allocate where the holes are, but you might have to edit it a little bit. So would you say that there maybe would you advise maybe going over like 10 notes per octave then? Would that be about too many holes or
I mean, you got 10 fingers, so
so you could
11
do
notes.
11, yeah.
Yeah.
Okay. I'm wondering also if Flutomat gives you any notes for other combinations of holes that you could hold down because you could get other chromatic notes from that. So,
Not like out of the box, but I mean,
but you could figure them out through trial and error yourself in theory.
yeah.
Okay.
I mean, they're probably not going to be like part of the initial scale. Like, there's a bunch of weird microtones, and they're not. The density is like all off. Like, if you like all the combinations of notes you could do, all there's six holes. You got turn them on or off, and that's like 2 to the 6th power, which
Yeah.
is like a lot.
Yes.
64 or something like that.
Yeah.
Like it's almost the same note for the most part
That
on a
was
lot
really
of
cool
them.
though, because
But
I heard the microtones coming really clearly through when you play that
yeah,
note
you
and then
get
you
a
held
bunch
that
of
two other
like
fingers. Yeah.
miscellaneous microtones that are micro relative to whatever you're tuning.
Yeah. Absolutely.
Super microtone.
That's really
Double
cool stuff. How many
double
flutes
is
do
in.
you have, by the way?
I have a lot. I've given away several, so I don't know how many off the top of my head, probably like 20 at least right now, and then like 15 or 20 more is given away.
Yeah.
I don't know how much they've been used, but they're
That's
available for
incredible.
people to play this harmonic music.
That's good, yeah. If we give away instruments, then more people are messing with them. I'm
Yeah.
finally getting enough instruments that I can do that, but I haven't figured out 3D printing, so it's like maybe
Yeah,
I
it
will
takes
after this.
about 5 hours to print a flute. So it's if you
It's not
time it
too
right,
bad.
you can get like 4 or 5 in a day.
Yeah,
And yeah.
not bad at all. Yeah, really cool stuff. Okay, I think there may be another instrument that I'm thinking of that you have. The death whistles.
Yeah, actually I made something out of that. I have to show it.
Do
Yeah,
tell.
be right back.
Yes.
So I took some death whistles and I took a trumpet and I made this.
Oh, okay. So there's a death whistle attached to each valve, right? All three of them,
Yeah.
and then
And
there's
then
one
there's the
in
one
the
at the bell.
bell.
So
That's
you get four
wild.
death whistles to choose from.
Man, I wish I could hear that.
Yeah,
But
it
yeah, okay.
sounds horrific.
So basically, it plays like a trumpet, and the death whistles you've attached, you had to calculate those to make sure they'd be the right kind of death whistle for that valve size, right? Or are they all the same size?
They're different sizes. Like there's If you have bigger ones, it doesn't like blow very well because you need more air to activate it, and so these are actually like from 12 EDO death whistles right now, but
Ooh.
they're not microtonal.
This is
Uh,
so cool. Even though it's 12 EDO.
yeah, I was starting to make one of a like a harmonic seventh triad, but it was like
Yeah.
the sizing is like weird or something, and my 3D printer messed up in the middle of that, so I need
I
to
guess
revisit
it
that and fix it.
it seems to me like the air of the trumpet might be really efficient in helping the death whistle sound, because sometimes I would try and play them, and based on the size it might be hard to make certain ones like make their characteristic sound, but then with the trumpet, if you've got it all hooked up, it's like as long as you can make that sound in the trumpet, it will sound the death whistle essentially,
Yeah, you
right?
don't even have to like make it sound. You just blow in the trumpet, and you don't even need a buzz or anything. So
Yeah, I
it
noticed
doesn't
that you
work
didn't
as
have a
well
mouthpiece.
if you buzz it. It's harder to do anything.
That's
It just
so
sounds like
odd.
extremely muted.
That's so weird. Why would that work? So the death whistle, it makes a sound kind of like a scream, right? Where does that come from?
It's from the internal shape of it. It's there's like an internal sphere inside of it that's somewhat shaped like the human larynx.
Yeah,
So it sounds like a human. It modulates this into a human-like scream.
it's great.
So I hope that comes through on the recording.
Yeah, we need more screaming instruments. That's true.
Yeah.
Great.
I don't know
Well,
what key it's in. I don't know what it's pitched relative to, but I also if you blow it really hard, like the overtones just go everywhere and like it loses like or if you blow it softly, you can like hear the pitch to it and like the relative like pitch harmonies and stuff, but
you saying that
you have to be at
maybe.
like a pianissimo to like even have a pitch,
Oh, that's so
discernible
wild.
pitch.
Right, so it's yeah, because I know that it's really noisy when you blow them. So you're talking about like the overtones kind of going everywhere, and it gets so noisy that you can't tell what the pitch is, or maybe you can still hear it, but it's just hard, maybe like a chime or something.
Yeah, it's really hard to like pin it down, I think.
Yeah. Oh, that's so cool. Well, Chris, thanks so much for giving us the lowdown on that. Could we maybe talk about your Banjo-Tooie cover a little bit, if you'd like to?
Yeah, sure.
Yeah. Okay. So, you made a little bit of a microtonal video game music, and in Banjo-Tooie, you've got essentially like an initial tonic major chord, right? And then
Yeah.
you're going to the flat six chord from there, and they're going back and forth, right?
Yeah, it's the Atlantis theme from Banjo-Tooie.
Right. This is which is like
Um,
underwater or whatever.
yeah, underwater, underneath Jolly Roger's Lagoon, you find this Atlantis place with like ancient flooded city stuff. And
Yeah.
it's got this music. Um, first part, like you said, yeah, it's just got a major chord, and then it goes down to the minor six of that, which is like a 5 to 4 below
Yeah.
the root. So it's shifting by that 5 to 4 ratio for it, the first part of it, just back and forth for a while.
Yeah. Yeah.
And then it goes into another part where it modulates through like a whole bunch of different chords. It like goes all over the place in this like crazy modulation pattern that eventually comes back to the way it starts.
Right.
And so I went looked through dug through the sheet music and analyzed it and discovered that that modulation tempers out the diaschisma 3 times. It's like the sum total of all those chords is like 3 diaschismas, and it's the same. It gets to the same point. The song was composed in 12 EDO,
Yeah.
12 equals. So that's tempered out there. So it goes to the same point. So I figured like anything else that also tempers that out could probably play this same song. So I picked 34 because it's a good tuning of it, and it's got like really nice fives, and I did it, and it sounds pretty great, I think.
Yeah, Yeah, the thirds are really beautiful in that. I think it works really well. So then, in tempering out the Daesh Gizmo 3 times, that has to do with the tritone, right? Because I was hearing in the chord progression that if you've got the one chord and the flat six, as you mentioned, which is a 5/4 below the
Hmm.
tonic, when you're starting that chain of sequences, you start with the fourth above that flat six chord, and you're essentially just moving by a tritone up from that, and then doing it again a half step lower, and doing it again a half step lower, and then one more half step, and then it just like teleports back, essentially.
Yeah, something like that, I think. Like the main melodic kind of thing, not quite melodic, but like the I guess the background, it's got this like do 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 do, like, and that's just like harmonically, that's like an 8, 9, 10, 12 chord, broken chord. So if you take it as that and then kind of extrapolate that shape and pattern of whatever stuff like that, it implies that the tritone is a 45 to 32,
Right.
basically,
Okay.
as opposed to like one of the other things that it could be tempered from and to make 12 equal. So taking it as that, that implies the diaschisma.
Oh, okay. Is that because 45/32 is also equivalent to some other tritone farther away in tuning systems that temper out the Daesh Gizmo, or is that
It's
unrelated?
it's no, it's because it's like 9/8 times 5/4 equals
Oh, okay.
45 over 32.
Yeah, yeah, yeah. Right. Okay. Neat.
And it's going to be the same as 64 over 45 because of the tritone equivalence.
Right, yeah.
So
Oh, okay. So I think I get the Daesh Gizmo now. It's kind of like Pajara tempering out
yeah,
7/5 and
it's
10/7, where it's like you have two tritones and they're the same. So you get
yeah,
half octave period.
yes.
Ah, okay.
Yeah, the this highly related to Pajara. Pajara is like one of the basic 7 limit extensions for it. So,
Yeah.
uh,
Also, did you do it a tritone away from the original theme on purpose? Because I thought that was very
did I?
poetic. Yeah.
Oh,
And I was like, oh, that's so perfect because it's the tritone we're
I
talking
just did
about
it
so
where it
well.
made sense on the Lumatone, like
Right, yeah.
learning it and figuring it out. So I wasn't trying to make it in any specific key,
Oh, I do
I
that too.
suppose.
After hearing this song and hearing the back and forth, I think to myself, wow, this is kind of a dream video game song for a microtonalist because I feel like so many microtonalists would like to hear songs that have quick successions of chromatic chords so that they can, bastardize them with the temperament or the inverse. So this would be a great song to do that in since it like does a certain thing 3 times that is chromatic. It makes me think about what might happen if you played this theme and you didn't temper out the Daesh Gizmo and maybe you like tried to maximize the distance between these three things so that the key you end up in is like you could do
I'll just
you
like embrace the shift of
yeah,
the pitch
embrace the
shift.
shift. I think you could really, in this one, you could get away with doing a lot of it and really end up in an unrelated key that's like a third away. Because I think in some microtonal chord progressions, when you try and do this, you end up with pitch drift. And so, like, maybe you only end up a half step away or a
Yeah.
microtone away or maybe even a major second. But this one, it's got the potential for really, really far distances. So you could just catapult into something unrelated, I think. That'd be kind of cool. The opposite of what you did.
Yeah.
Yeah, yeah.
It's
I also really
tempered
like
in.
the low melody sounds and synth sounds. That's kind of cool. It makes me feel like there's kind of like a different note in the bass at times when it's switching between the two main chords. Is
Hmm.
that part of the main theme? I noticed it was part of yours, but um
I think so. I mean, I
yeah.
mostly just like went off the sheet music that I found. So
Yeah.
I guess it's like doubly transcribed.
Yeah. Yeah.
But yeah.
It's good stuff. All
Yeah,
right.
there's a lot of a lot of songs, if like there's like weird chord progression stuff going on, you can like analyze it and figure out like what like the overall sum total of like the entire chord progression, and like that's usually points to like some non-mean tone, non-syntonic comma that's tempered out, and you
Yeah.
can use that as like a launch pad to some other tuning. Like another song from Banjo-Tooie, the Hellfire Peaks track, which is one of the later stages. That one tempers out the ripple comma,
What? No
and
way.
so you can do that in like 23 EDO.
We
So
clicked on Ripple earlier and I've been obsessed with 23, so this is hitting a lot of buttons for me.
yeah,
Very good. So
I
wait,
have to send. I have it written down. I'll send you a picture of it, I guess, or.
Yeah, send me that.
Yeah,
I'm looking up ripple temperament because I'm slightly unfamiliar, but let me see if I can.
yeah. The Moss is like really boring. It's like almost just 12 EDO, but
Sounds like schismatic,
it's
but more boring than that.
but in terms of like chord progressions which come back to the same spot,
Yeah.
it's there's potential, and the Hellfire Peaks does it because that one also has tritones.
You know what? I actually used your Projective Space tuning app to quickly generate Ripple 12, and I see that it is just generated by 102 cents, and
Yeah, it's boring.
it's just 12 of them in a row. It's basically 12-10.
Yeah.
What is going on? That's so weird. I love that. Very cool.
Yeah. Yeah, another one I found out, Knights of Sidonia is in augmented temperament. Like,
Yes, that makes sense.
yeah, because the initial verse thing, it like modulates by 8/5 each time, and it does it 3 times, and it comes back to the start.
That's right.
So
Yes.
I learned that on the 15 tone ukulele now, and I can play it
Oh,
with
that's cool.
pretty,
Yeah.
pretty decently now.
It actually seems like you're finding songs and you find a temperament that would work with a chord progression using something in 12 EDO, and then you play something that's in that temperament but in a Zen harmonic tuning system. Well, I think I am just about out of time, and I'm glad
All
we got
right.
to have this conversation. Really looking forward to a lot of people using your Projective Tuning Space app, and I'm sure tons of people are using it already, but I want to, of course, grow the conversation around that because it's such a useful tool. What would have taken me a long time to figure out on the Zen Harmonic Wiki by parsing obtuse numbers together that shouldn't be together took me like 2 seconds on Projective Tuning Space to figure out, what ripple was. So,
I use it a lot. I made it because I wanted it to exist, and then I put it out on a website so other people can use it too. But
right, yeah. So I guess I can promote your YouTube channel and Projective Tuning Space. I think that's pretty much all we got then. So thanks for coming on, Chris. I had a great time. Looking forward
thanks
to
for having me,
releasing the
Stephen.
episode. Yeah. All
All right.
right. I'll see you later.
All right. Thanks. Bye.
Bye. Thanks for listening to this episode of Now in Zen. You're currently listening to another rendering of Chris's, that of the Dungeon theme from The Legend of Zelda. You hear there that the minor thirds cover a slightly different distance than they normally do, so that when they arpeggiate upwards, they get deformed. If you enjoy this podcast, be sure to leave a positive review on iTunes and spread the word. We also have a Patreon account, which shows details from microtonal transcriptions and covers. Our next episode will feature Kari Ikonen. Thanks so much for listening, and catch you next time on Now in Zen. A special thanks to our Zen Harmonic patrons, as well as our Zen Harmonic gods. Jundai Bates Kobashigawa, Naren Rattan, Adam Freese, Matthew Sheeran, Hector McGuffin, Leland O. Weigel, Amy Coleman, Jill Weigel, and Tina Harmon Carto.